In the previous video, we made these training error and test error dictionaries, and we saw that in general, the training errors, they always go down as the degree gets higher, okay, as the flexibility of the model increases, whereas the test error goes down for a little bit and then eventually starts going up. And like the more it goes up, the more sign there is of overfitting. Like here, where we were using a much smaller training set, where we were using just 20 points for this one. So this is a very common phenomenon. Like this is a picture I took from the book Introduction to Statistical Learning, which is where I learned a lot of the like underlying mathematics or statistics behind this material. And so here it's showing how, so the red curve indicates the test error, and it's saying the errors goes down as flexibility increases to a point, and then once overfitting starts, the test error starts going up again. Whereas for the training error, that training error just always goes down as the flexibility of the model increases. So I want to see if I can reproduce this image from that textbook. So I'm going to plot it using Altair, so I need to get my data, which is stored in dictionaries. I need to get that into a data frame. So I'm going to say pd.dataframe, and then let's try to just use this. Let's start with the training error dictionary, and let's see what happens. So that part doesn't work yet. So let me instead call this how about y? Okay, so I'm going to say y should have these values. Okay, perfect. So here, this is the training error. So notice how these numbers are always going down. And let me add another column that I'll call like type. And then in this column, I'm going to put train. Okay, just to remind me that this is from the training data. Okay, like this train here. Okay, great. And so let's call this, how about df train? And then let's make another one for a test. So df test, this is going to be another data frame. This is going to be from the test error dictionary. Remember, these are the ones that only used 20 of the training points. Okay, and the type of this one is going to be test. Okay, and let's just look at that df test. See if I made it okay. So again, this is the one where it goes down until it reaches the true degree and then starts going up and then goes up like rapidly once we get to degree 5. Okay, perfect. And so I have these two data frames. Okay, they have the same column names. And let me show you a way that we can join them together. I can say pd.concat for concatenate. And then I'm going to put them into a list. So df train followed by df test. And so that just sort of stacks them one on top of the other. And I'm going to do something here, which is I care about these numbers on the outside, like this 6 corresponds to degree 6. And so I'm going to say on the outside dot reset index. Okay, and so then that puts it here onto the inside. So this is degree 1, degree 2, and so on. Okay, and let me call this, how about df small? Okay, why small? Because it was using the small training set. And now let's try to plot it. So altair.chart, df small. I'll do a line plot for this one. So mark line, dot encode. And so x is going to be the, okay, so what were the names here? X is going to be what's called index here. So x equals index. Okay, the y value is going to be what I called y. And to distinguish them, I'm going to say the color equals. And what was this column called? This column was called type. And so to make it a little easier to look at, let's specify the scale. Let's say it's just supposed to be up to, how about 2000? Okay, so instead of going up to 20,000, so let's say clip equals true, and then I'm going to specify a scale here. So alt.y scale equals alt.scale domain equals 0 to 2000. Okay, and so for the test error, goes down as we reach 2, stays down for 3 and 4, and then it shoots up. And if I don't want these to show up as decimals, I could say this should be an ordinal type. Okay, so now it's just like degree 1 to degree 2, and there's no such thing as degree 1.5 in this kind of context. So that's why ordinal makes sense in this case. Okay, great. And you can see that the training data is able to be fit much better. Okay, that corresponds to it being much lower here. So let's try to do the exact same thing with the bigger data set. Okay, with the bigger training set, I should say. So all I want to do here is put this suffix 2. And let's also put a suffix 2 for both of these. Okay, so this is the one where, because I'm using so much more training data, the overfitting isn't as bad. And then let's concatenate them together. Okay, with this df small. Okay, but this one, instead of calling it df small, I'll call this df big, since it's using way more of the training data. Okay, good. And now let's try to copy this this chart. And remember, this is supposed to look like a sort of real-world version of this image from that Introduction to Statistical Learning book. Okay, so here is the test error. This one that's constantly going down, that's monotone decreasing, is the training error. The constantly decreasing one is the training error. Okay, and let's plot this using Altair. So here I want to use df big instead of df small. And I think that's the only thing I should need to change. And so let's see, did something wrong here? Do you see what it is? I didn't use df train 2 and df test 2. Okay, and so this is what we get when we use much more training data so that there's not as much overfitting. There's still underfitting at the beginning, but then things really smooth out once I get to this degree 2, even as I increase to higher degrees. Using those 800 training sample points really gives me kind of a similar amount of accuracy. And in general, this won't happen, but you can see in this case, the test error is actually less than the training error, which is a good sign that we're not overfitting in this case.